Hello and welcome. It's nice to have you join us again today on NASENI Milestones. In economics, it's widely accepted that technology is key driver of economic growth of any nation because it allows for efficient production of more and better goods and services, which are what prosperity depends on. In Nigeria, the only agency that has the capacity to stimulate technology-driven industrialization is the National Agency for Science and Engineering Infrastructure, NASENI, through its research institutes such as Electronics Development Institute, LD, in Oka, Anambra State, which has excelled in reverse engineering and indigenous production of electronic and electrical products, problem-solving products in the areas of education, energy, agriculture, security, and ICT. Nigerians need to understand that no nation has ever become great without homegrown technology. And the essence of this program is to prove the fact that the nation has what it takes to grow technologically in terms of manpower, creativity, and raw materials. There are a lot more to learn from Nigerian scientists and engineers who are devoted to research and development of electronic gadgets and devices aimed at reducing overdependence on imported ones, as Nigeria has often been described as a huge market for foreign electronic products. We begin today's program with a visit to the Electronics Development Institute, LD, Oka in Anambra State, one of NASENI's centers of excellence, to see things for ourselves. My name is Kirian Umayo. Thank you for joining us, and please do stay with us. The Department of Mechatronics has successfully produced some indigenous electronics gadgets to address the needs of the society. There is DigiScale, which is a digital scale system, unlike the analog balance scale. A digital scale is a high-quality scale that gives a more correct weight reading. It's also called a digital gram scale to measure the weight or mass of an ingredient expressed in pounds, grams, fluid ounces, and millimeters. The department has also developed a device known as programmable timer switch used in regulating energy consumption that controls energy wastage at homes, offices, and factories. It is an energy-saving device. Another major device from the Mechatronics Department of Electronic Development Institute, LD, Oka, is Logic Gate Experimental Kit, a teaching and learning device for science students at higher institutions of learning. Engineer Osohi explains these devices.
The product I'll be talking about, they are all clustered here. This is DigiScale. The DigiScale was given as a challenge to this institute a few years ago from NIPOST. The level where we are now is that this DigiScale can weigh anything. Because, like I said, it is a demand-based, research-driven product. Right as I speak now, it's not only targeted to NIPOST. Any food shop can use it. Meat selling vendor can use it. Anybody that weighs something, apart from human scale. The one we have for human scale is we are still researching on that. That one is going to be a full-blown product. But this can weigh anything from 5 grams to about 50 kg. So the next product here is programmable timer switch. Like I said, we don't just go into research. You go into research based on what's a particular problem to solve. So people started complaining some few years ago that the cost of electricity is very, very high now. And many of us don't even know how to control the one that we buy. So we came up with this product to help us regulate the little one we have available. Like, for example, now, if you have a fridge at home, your fridge can remain on even when it is fully frozen. Once your fridge is fully frozen, it will be drawing so much energy from electricity, while it's not doing much. So with this particular product called programmable timer switch, you can program whatever device you want to put on at any particular time and also determine when you want it to go off. By so doing, you are going to save enough energy. So the next one close to it is logic gate experimental kit. So this particular product, anything about digital electronics, of course, you know digital electronics is revolutionizing the whole world now. You can do anything about digital electronics on this board, both in emulation state or in a physical state. You know, you can do anything. As you can see, this is LCD, directing you what to select at any particular point in time. If you want to test single input logic gate, you select it. If you want to test 2 input logic gate, you select it and you perform your experiment. Whether you have the logic gate at hand or you want to know how they behave. It's not just reading it from the textbook. You want to actually know what they behave. You can select the emulation state and you know what they do. And you go happy as a student. This is the next product. It's called Consumer Energy Monitor System. So we are trying to profile a solution to a building where you have a single meter where many people are using it. You know, it's always a problem. The solution was to build a first system. This was the older version, and this is the newer version of this. This is the newer version. This was the first version we built. So what this system does is that just connect your building or your apartment to this system. Then this system is connected to the general electricity consuming meter, the one that comes from discos. So once this one is connected to the meter, for a start, we just came up with 4 channels. We can increase it to how many channels you need. What I mean is that if we have a building where we have up to 6 individuals, like 6 flats in a particular building, we can connect each of those flats to this particular system, whereas this system is connected to a general meter. At the end of the month, this system will tell you what you consume. I'm not just telling you what you consume, we also tell you the equivalent amount that you are to pay. This thing came up many years ago as a challenge from the Nigerian Football Association. They said they don't want to import the foreign ones, not just for football alone. You can also use for any other sporting activity that requires timing and that also require exchange of players. So what this thing does is just player substitution. And we did it. It's working perfectly.
As part of NASENI's intervention in the education sector, LD Oka developed electronic science kits of different categories. Engineer Oladapo Olatoye tells us more.
This is a power electronic experimental kit. This kit was developed because of the what we know about the challenges of education in Nigeria. So we went to schools and were able to get that, unlike some other subjects, that electronics, they don't really have science kits to demonstrate what they are teaching in electronics. So we came up with this, which is on power electronics. When we say power electronics, we are talking about how to use components to achieve some experimental results. So that's the reason why we constructed this. This have the KVL and KCS circuits, which is a circuit that you can use to get your catch-off voltage law and catch-off current law. You can demonstrate it through this circuit. You can demonstrate resistors in series and parallel. You can combine resistors, and you can also do superposition principle. You can try many things concerning the issue of just basic electricity on this particular board. We have up to 4 boards here. The first one is on KCL and KVL. The other one is on rectification. When you talk about rectification, is the process whereby you change AC voltage to DC voltage, which you can use this to demonstrate how there can be rectification and how you can build your power supply. So that's the essence of this. And we also have the demonstration of an op amp, operational amplifier in this place. So anything that relates to that, you can demonstrate it here. So that's the major thing about this. But we now have a newer version. We have 9 modules, which I'm going to show one by one. We have the one of basic electricity. You can see it here, basic electricity training kit. We also have the one on sensor op-amp training kit. It's also here. We have the one on rectification. We have the one on solar power training kit, and we have electronic multivibrator. So we have that. Then we have a oscillator experimental kit, and also we have transformer training kit. Then here we have the logic gate experimental kit and embedded system training kit. Now I will just talk about some of these just to let you know the way they work. Like this embedded system training kit, we designed this to be able to train students, especially in higher institutions, like undergraduate students. We designed it to be able to train them on how to actually make use of their program and see how it works practically. If there is a particular student you are teaching how to program, the person can write a small program. When the person writes a small program, after debugging it, then you can now bring it to this place, put it in the Arduino training side, Arduino board. When you put it in Arduino board, then it can show the way the program is written, and also show you whatsoever that need to be changed there. Then apart from that, we have already written some programs, pre-written programs, which we have already put here so that you can use to demonstrate. If you press one of these switches here, we have switch 1 to 8 here. It indicates different programs that we have already put inside that we can use to show students. Like this one now, by pressing this, the LED will indicate the way it's supposed to be. And also we have some sensors here that can also sense maybe light, so that you see the effect on the program that you have already written. So this is the essence of this. And if there are components you also want to put, you can also use the component and use it to demonstrate the program. Then this one, logic gate experimental board, is similar to the old one. This one is to train on logic gates. What are the logic gates? Our hand gates, our OR gates, our NOR gates, and our OR gate. All these, there are 4 gates, though there are many other gates, but 4 that we put here. We also put it in such a way that you may have 2 inputs, or you may have 3 inputs. So all these things can be selected here. This one now is for 2 inputs. If you want to demonstrate, if you press 2 inputs, okay. So this one will demonstrate that for you. Then the one on basic electricity is connected here. You can see this LED is on, showing that whatsoever you put at the input at this side, you can get indicator at the output depending on the experiment that you are doing. Like now you can do experiment on current. You want to know how current relate together both at the input and the output. This can be used to do it. Then we have like this one now, it has oscillator, so that any kind of signal that you want to make that you are trying to rectify, when you rectify AC and you become DC, you can easily monitor it on the oscillator. So with that one, the student can be able to see it practically, how the rectification is being done and the output that is expected.
All products at LD are tested in the course of production at the Microelectronic Laboratory, as Dr. Oluwaseyi Ogumbenro explains.
Once our engineers finish their R&D work, the soft design, and transform that onto PCB, they bring their work into this laboratory to run tests. As you can see, we have different equipments ranging from power supply system. They generate power for different products to power the PCB before the packaging section. That's a stage of production. And that's a power supply system that can give them any voltage they need for any of the products, the DC voltage. From there, we also have a digital multimeter and universal counter, a function generator. If they need to generate frequency of different type, square wave, triangular waveform, sine waveform, they use this, introduce the signal into their circuit. Of course, we have analog and digital oscilloscope. It's an example of an analog oscilloscope. I'm still going to show you the digital oscilloscope. We have them here. Whichever one that is needed, applicable, is used for the project at hand. This is another laboratory power supply, digital power supply. So more than one person can be working at a time. And this is an example of a digital oscilloscope. We have this, and we also have handheld ones. At times, they might be allowed to sign out these, take into their department to do one or two work to check the waveform of their devices. Of course, we have some other works also on electromagnetic radiation. This is an electromagnetic radiation meter. You can see that. And then we have some other sensors also. Generally, in this laboratory, what we do is to run tests and also do some soldering. This is a workstation where electronics component can be soldered on the PCB before it can become the product you have seen in the other showroom. This is a spectrum analyzer. You can see it there. And this is another power supply. And this is a 3D printer. It's a 3D printer. And here we have series of testers too. LCR tester, clamp meter, and the likes. And there we have a variable transformer, a voltage regulator. So just like we've talked about designing a stabilizer, these are some of the things we use to calibrate our electronic circuits, even before you fix the main transformer to arrive at the final stabilizer. So generally, this is where we run the tests.
Amazing successes recorded at LD Oka. We saw products by the mechatronics unit, the science education training kits and associated devices, consumer electronic products born out of reverse engineering, plus home-initiated products yearning for commercialization and mass production. This, to a large extent, explains NASENI's readiness to launch the nation into an industrialized nation via local technology. Next, let's hear from the man whose passion and unflinching support for indigenous technology cannot be overstated. He is the architect of what is today known as the new NASENI, the executive vice chairman of NASENI, engineer Professor Mohammed Sani Haruna.
I am always happy to be with you. And thank you very much for your interest in what our Electronic Development Institute, LD Oka, is doing for us and of course for the nation. Now, the institute is set off basically to do research and development in the areas of electronics and communication equipment. And despite the challenges of the past, there has been remarkable achievement. So many products have come out on that. One thing that I should say from the beginning is that it is part of the LD's mandate, Electronic Development Institute, to research and produce equipment of capital goods that uses automation, that apply the principles and concept, of course, of artificial intelligence in the production of things. For now, it is the only institute in this region that produces training equipment in the areas of computation, in the areas of communication, in the areas of electronics, digital circuits. These equipments are essentials because our challenge, we produce engineers who graduate and they are supposed to work in industries, but they have never seen this equipment before. Now, the production of this equipment that we are doing from our centers and LD of industrial grade, of industrial standard, are useful not only for industries that used to come to us in what we call retrofit. What we call retrofit, for example, you have some smart card, you have some electronic cards that is used in manufacturing and in your production line. Suddenly is faulty. That component, you have nowhere, or you have difficulties in ordering it from abroad, or because of exchange rate. You come to us, we are able to study exactly what that component is doing to you. And we produce through different methods, different size, using different component, but will give us exactly the same output as the original. This will call retrofit. Now it is in LD that we conduct this research and development. And there are some industries that approach us, and we provided solution in their smart card and some electronic cards in the control and automation equipment like that through this method. Now, the component you have seen in logic gates, in microprocessors that we produce locally, automation devices, and other modules of electronic training. As I said, so many engineers graduate from our universities without even seeing this, that they are supposed to use and understand it. Now we produce this for industrial consumption and uses it also for training, the trainers and the student as well.
Engineer Dr. Patrick Uku, the Managing Director of LD Oka, he will provide more information regarding the operation of the institute.
LD has a mandate for research and development of electronics products and seeding out our research findings or our prototypes or our inventions to the private sector, private entrepreneurs for possible mass production. LD has, we have a whole lot of electronic engineers, software engineers, there's computer scientists, IT, and some supporting staff. And we have over 15 PhD in our R&D section. That actually keeps LD in the forefront of research and development. So in terms of manpower, LD is doing well. We have the capacity and the capability. LD has a lot of homegrown technologies that addresses every sector of the economy, like the agricultural sector, the power sector, the security, and the educational sector. When it comes to the agricultural sector, we have products like our poultry management system. Actually, what it does is a poultry cage system that all the functions are automated. That you have the water, the feed, egg collection, everything is done automatically. And you can actually operate, you can actually program it to function with time, or you can even operate it using a remote control systems. So you can operate, you can actually feed your birds by seeing them on your screen, and by pressing buttons, the feeds will be put in their feeding cans without you actually being there. You can actually give them water without being there because it has cameras, you're seen from a distance. Then you can actually program it also to do it automatically at intervals, depending on how you want to operate your system. So in that case, we encourage graduates that to go into farming. And then in our power sector, we have developed a whole lot of products that will help our power sector. One, the ones that will save power, which is our 5-watt bulbs. We have our bulb, the power is 5 watts, but the intensity is actually up to 60 watts. But the power it consumes is 5 watts. And that is the technology. And we made sure that this bulb, even from 50 volts, it gives you the highest illumination. and it can tolerate very high voltages, up to 390 volts. The bulb is still working. So it's a very, it's one of our very good products that we developed that will help to save power. We try to balance the system by developing inverters. So with these inverters, we can have alternative energy that will actually help our PHCN.
We shall bring you part 2 of LD Orca electronic products in our subsequent editions of NASENI Milestones. And that's our program for today. We thank you for watching, and do join us again next week as we continue to navigate NASENI's technological advancement. My name is Kirian Umayo. I will see you again. Bye for now.